Hello, science enthusiasts, and welcome to another episode of Beacon Bin Science. Today, in this video, we are going to talk about the conversions, the organic chemistry conversion of functional group. You know how important is the conversions in organic chemistry. And in this video, we are going to tell you about 7 conversions of functional group that will going to help you to ace your interviews, whether it is a PhD interview or industrial interview or even in your exams. These conversions are definitely going to help you. Now, the best part about this video is that after learning these conversions, you will be able to convert these functional group in just 1 or 2 steps. So stay connected till the end because this video is going to be very informative if you are going to appear in your interviews. So this video is about mastering the top 7 organic chemistry most important conversions that will be useful for industrial interview. Now, one by one, we'll look into these conversions and we'll see how we can do this conversion. So number 1 is the conversion of alkyl halide to amine. This is very important question. This X group resembles the halide group, whether it can be a chlorine, bromine, iodine. How you can convert this alkyl halide into the amine, alkyl amine. I'll give you 5 seconds to think about it, how you can convert it. The answer is we can do it by these 2 ways. First is the Schrödinger reaction and the second is the Gabriel reaction. If we look into the Gabriel reaction, we have to use the phthalimide group. This group is known as a phthalimide group, and when we in the presence of the base which is having the OH hydroxy base, we perform this reaction. When we react this alkyl halide to Gabriel phthalimide, it converts into an amine. So we will see the mechanism for this reaction. First, what happens? This phthalimide is having a N minus, which will give it a nucleophilic character. This nucleophile attacks to this alkyl halide because the halides are a good leaving group. So through SN2 type of mechanism, it reacts from the backside and then forms this complex, which is having a CN bond. Now use the sodium hydroxide. The sodium hydroxide will attack to this C double bond O group, the amidic carbonyl group, which will finally convert it into the phthalic acid and amine. That's how we can convert the alkyl halide to amine through Gabriel reaction. Now we'll look into the Schrödinger reaction, which is very important. So in the Schrödinger reaction, what we will do, we react this alkyl halide with azides, sodium azide basically. So in this azide, the first it will form the alkyl azide bond, and then we will use the triphenylphosphine group to finally convert into amine. So we will see into the mechanism of this reaction fast. So alkyl halide, again in the same way the SN2 type of reaction happens because this azide is having a negative charge over nitrogen, which provides its nucleophilic character. It's attacked to this place and form a alkyl azide bond. Once the azide bond forms, the triphenylphosphine, which is having a lone pair of electron, and this nitrogen is actually electrophilic in nature because the next nitrogen is having a positive charge, which will allows it to pull the electron towards itself. So once it start pulling its electron towards itself, the triphenylphosphine will attack to this nitrogen and form this type of bonding, which is having a positive charge and then negative charge over here. Now this positive and negative charge will attract to each other and forms a bond. Once this bond will be formed, the PN bond will break and it will give a N triple bond N bond formation, which finally releases the nitrogen from this reaction and it will form the N double bond PPH3 group. Now we can see it here, this nitrogen is more nucleophilic, so it will attract the electron towards itself, which creates the dipolar type of the molecule having a nitrogen having negative charge and phosphorus having a positive charge. To balance it, the nucleophile will attack to this phosphorus and then it will finally form the TPPO molecule and leaving behind the amine. That's how you can make amine from alkyl halides. This is very important reaction, and most of the time they can ask you to convert alcohol to amine or any other thing to amine. It's simple. If you wanted to convert the alcohol to amine also, by the same method you can do it. First you convert the alcohol into alkyl halide, and then alkyl halide into amine. We are going to move into next conversion, that is a carboxylic acid to amine. This is also very important, how you can directly convert this carboxylic acid COOH group into the amine. So I'll give you 5 seconds to think about this conversion, and after that I'll tell you what is the way to do the conversion. Yes. So the conversion can be done by the Curtius rearrangement. This is very important reaction. I'm telling you, this conversion is the most important conversion that many times interviewers or even the exams comes directly, like conversion of the COH group into amine. So how you can do this? This Curtius rearrangement reaction starts with the conversion of acid into acyl chloride. Once you convert this acid into acyl chloride, then again this same type of reaction, nucleophilic SN2 type of reaction, the azide we will use group sodium azide, and this sodium azide will react to form the amide type of bond. Once this amide bond form, the conversion in presence of heat will take place, and this rearrangement will helps to convert this amide into an amine. Now we'll see the mechanism how it happens. So once this forms, the amide kind of a bond formed, then on heating, this nitrogen is having a negative charge. It will it will shift its electron towards this positively charged nitrogen, and then this electron shifts towards nitrogen, which gives this nitrogen a negative charge and this a positive charge. Now this can be easily removed or easily leave from the molecule as a N2 nitrogen. Once this leaves this group leaves the molecule, then the rearrangement happens. This negative charge goes towards the NC bond, and this alkyl group, which is attached directly to the carbon of the carbonyl group, will shift towards the nitrogen. That's how it forms the isocyanate type of intermediate. Once this isocyanate intermediate forms, the water will attack to this carbon, because this is a electrophilic carbon attached with oxygen and nitrogen. Then this bond shifts towards the nitrogen, and finally it will convert this CO into CO2, and the removal of the amine group will take place. Now third conversion we'll talk about is alkyl halide to aldehyde. You have to pressurize your mind to think about it, how you can convert this alkyl halide into aldehyde. I'll give you 5 seconds, think about it. So this conversion we can do by using the Bovard aldehyde synthesis. This is also a very interesting reaction, and this conversion you can do it in a single step. How you can do it, I'll show it here. So first, the alkyl halide we will be reacted with the metal like lithium, magnesium, sodium, potassium type of metal, and then followed by the addition of the DMF, and in the end we will do the acid hydrolysis. So how this reaction will happen, we will see it in this mechanism. So first we will introduce the metal like lithium. So lithium will replace the halide and form the RLI bond. Now once this RLI bond forms, we know that here the R is having the negative charge and lithium is having a positive charge, which this negative charge, it will become a nucleophile. Once this nucleophile formed, then we will introduce the DMF. So this DMF will be the source for this carbonyl group, this aldehyde carbonic group, for group source. So now this R minus will attack to the carbonyl of this amide, and then it will form the RC bond and having the OLI. Once this formed, now when we do the acid hydrolysis, it will it will form this aldehyde group, and the removal of this amine, secondary amine, will take place. That's how you can convert the alkyl halide into aldehyde. Now moving on to the fourth conversion, that is the ketone to amide. So this can be done by the Beckmann rearrangement. In Beckmann rearrangement, what we do, we convert this ketone into an oximes by using the hydroxylamine. Once the hydroxylamine will be used, it will convert into oxime, and with this oxime we use the acid group. This solution of HCl will be introduced. This will form the rearrangement. This will allows the rearrangement of this oxime to give the amide. Once the water will be removed from it, the rearrangement will happen. The alkyl group will shift towards the nitrogen and form this intermediate. Once this intermediate form, you can see it here, the positive charge will be generated over here, which will be attacked by the nucleophile like water, and then it will form the amide. Now, moving on towards the fifth conversion, and that is the homologation reaction. One carbon addition next to the carbon group. How you are going to do it? You can see it here. There is this alkyl group, and next to this alkyl group, there is a COH group. Now, if I say that we have to introduce one carbon CH2 group next to this carboxylic acid, how you will do it? Think about it, and then I'll show you how we can do it. So this can be done by unstart homologation. This reaction follows the conversion of acid into acyl chloride. With this acyl chloride, we react the acyl chloride with the diazomethane group and along with the catalytic amount of Ag plus and water. What happened here is this diazomethane will act as a nucleophile here. Now we can see it here, the structure of the diazomethane is CH2 minus and N plus. Now this will attack here to remove the chloro from the acyl group, and it will introduce the CH2 group here. As we know, this will be a good leaving group. This nitrogen N2 will be a good leaving group. It will leave, and once it leave, the rearrangement will happen, and this R group will shift towards this and form this ketene type of bond. Once this ketene intermediate will be formed, then this nucleophilic water, the oxygen having a lone pair, it will attack to this carbon, and then formation of the acid will take place, and with the addition of one carbon next to the carbonyl group. That's how we can introduce the carbon next to the carbonyl group. Now moving towards the sixth conversion, that is the aniline to aryl halide. This is simple, I guess, right? I think most of you have guessed it, how you can do it. This can be done by the Senmeyer reaction. First, we will convert this aniline into a diazo salt by using NaNO2 salt in presence of HCl. Once this diazo salt forms, then we can use the copper chloride or copper bromide, whatever the halide we wanted to introduce. We use the copper molecule of that, and then we can introduce the halide to this group, and that's how we can convert the aniline into an benzyl halide. Now moving towards the seventh and the very important conversion, and this is also very important because this conversion will help you to get the enantioselectivity in your molecule. How you will convert the ketone into alcohol with having a specific optical rotation, either S or R. That can be done by Corey-Bakshi-Shibata reduction, CBS reduction. In this reaction, we use the CBS reagent. This complex, which you can see it here, is known as a Corey-Bakshi-Shibata reagent. This is very important, and you have to learn this reagent structure. Once we use this reagent along with BH3 and the solvent in room temperature, we can convert this ketone into an alcohol, which is having a enantioselectivity. Here you can see we got the S symmetry. That's how we can convert the ketone into an alcohol which is having an enantioselectivity. These are some of the conversions which I have extracted out from the pool of so many conversions, and I think these are very important conversions, and if you know these conversions, it will definitely going to help you in some way or the other. So I hope this will be a very informative video for you all, and if you find this video interesting, and if you have any other conversion you wanted to know or you wanted to discuss, then you can use the comment section. It is free for you all, and I hope to see you all in the next video. Till then, stay safe, be happy. See you in the next video.